Hi, my name is Christoph Mütze, possibly better known as Gizmo, as my scene nick. I'm from Farbrausch, and next to me is Thomas Malke, aka Fiverr2 of Farbrausch. And we are here to tell you a little bit about the content creation. Here's that next slide. For Krieger, which is this 96 kilobyte big game, which you just have seen in demonstration by Chaos. Give him a hand. Big player. And yeah, we just dive into.
Okay, we are starting at the very beginning, and that very beginning was a demo called Kasparov by Elite Group. And that demo featured mainly a lot of industrial objects. And when it was released, I had a chance to look at the textures and how they were made in Photoshop. And when looking at those textures and how they were made, I recognized that that they used the same patterns and Photoshop filters again and again. And some of you might know the film P. It is about a mathematician who is searching for the world formula, so, a formula that explains everything. And on his way to finding this formula, he's looking at the world around him, and everything he looks at, he sees patterns. He sees patterns in the milk and how it spreads in his coffee. He looks at the smoke of a cigarette, and he sees patterns again, and he sees trees and the leaves and how they are waving in the wind. And yeah, again, that's patterns. And
that's basically what we took as an idea and wanted to create that for 64 kilobyte intros. And we wanted to use this technique, and we did some of these patterns from the formulas and wanted to use them. And yeah, we thought, okay, scripting is a solution for that. Of course, it is. But as you can see here in this nice little whatever, I don't know what it's called, the very first 64K intro, the product, that we released in December 2000, used more than 3,000 of these formulas with parameters. And you can imagine that this is not a nice thing for a graphician to edit. It's terrible. So this was definitely no option for us. It may be for a coder, but not for a graphician. So we decided to use tools. And our tool, we called that Werkzeug. It had better turnaround times for us, of course, because it's much easier to do something visually than per code. We had instant feedback, which was very important. Everything we did was every parameter we dragged was directly shown in the engine, and the data was much easier to manage. And we even did some advantage over the classical flowcharts. We did this operator stacking, which gave the intro much more power, even if it's a very simple addition to the classical. It's much more better organized and much cleaner to work with. Yeah, and yeah, we started with textures. This was the very first approach we had.
The textures is where it all started, and we started with the patterns, and you see some of them here. On the left is a simple cloud texture, which is basically the same as noise. It's both Perl and noise. And in the middle, you see a cell operator that is used to make those structures that look like you can make stones with it, or cracks for floors and stuff like that.
Just to add, we have this etc., but I think these are the only ones we have, right? Isn't it? Do we have more?
That's the most important ones.
Yeah, I think so.
Yeah,
too.
you can. Of course, we have the glow rect or rect glow, which is on the right, which is a combination of a rectangle painter and a glow painter. You can define every form that's between those two basic forms. And that's very important if you want to make technical looking stuff.
Primarily, every texture we developed for the game started with one of these. So it's important to know, I think.
Yeah, another step is deformating those simple forms. And you have basically the blur. That's very important for all kinds of deformation stuff. Then you see the twirl, which is good for making abstract forms. One of the very most important ones is the bump mapping. There is no without the bump mapping, nothing of this would be possible.
Yeah, beautiful results, really.
In exactly every single texture, there's bump mapping used. And then we have stuff like distort and a usual rod zoom.
Of course, we're demo sceners. We have rod zoom.
Color correction is another step. Most of you know this probably from Photoshop. Basically, everything we do is pretty much the same as in Photoshop, but we use it in a very different way. For example, we have hue, saturation, color, contrast, and brightness in one operator, which is much more comfortable than in Photoshop, which is much slower. Photoshop is slower.
Yeah, slower. We are faster.
Yeah.
Well, no surprise, I think. And this is really important. I mean, the color correction. As you can see there, we really backed for quite a long time to get this color correction, because with color correction you can do everything. I mean, we will come to this later with the wood texture, why it is so important, this color correction. I mean, the graphicians between you know why it is important, but the coders don't seem to know that sometimes.
Okay, next step is the texture combiner. It basically exists of adding, subtracting, and multiplying textures, and we also have alpha mask. And yeah, this is the step from one-dimensional texture creation to two-dimensional texture creation. And it opens very much possibilities, because you can combine simple textures to newer ones, as you can see here. In the upper row, there you can see how dirt is added to a simple texture, and on the downside, you see how dirt is added or it's rust that is added to the dirty texture. Here's another little trick that is used very often in our intros for the textures. It's outlining. You just take the first texture, a generally basic black and white texture, and you make a copy of that and blur that and subtract the both versions from each other, and then you have those outlines which you can use for basically everything that's dirty. And yeah, that's used in every second texture.
Yeah, the wood texture.
Okay, and here we have some examples of textures that were made with our tool, the Werkzeug. First one is wood. Wood was the very first thing that was ever done with this technique. And you can, if you look at this texture, you can already see probably how it was made. You just have to imagine noise, basically just some dots, random dots, which are blurred into one dimension, so that you get stripes. Those stripes at some parts are twirled to get those wooden holes. And another important step is for every kind of texture is the colors. A brown texture always is very near to a wood, even if the structure is not right. So if you have the right colors, you are already very good on your way to the final texture.
You're much more. You want to forgive that it's not the perfect wood texture. If the color fits and the mood fits, everything fits. So this is a fake, in fact.
Okay, another texture is concrete. Again, you start with a very simple cloud texture, and then you use clouds and noise and a rod-zoomed glow rectangle for the bump map that you see there. And the colors are very easy in this one, black and white, and the result is pretty much close to concrete. This is very obvious how it was done. You see the cell operator everywhere to make those stones. And over those bumped cells, there's added some noise. And in the end, it looks kind of like stones would. And another bonus in this texture is that you can use the bump that you use for the texture also as the real-time bump texture, which means that you can throw a light over it, and in real time, in the game or in the demo, the stones will reflect the light correctly, and it will look three-dimensional. This is a G.
G as in Gizmo.
Exactly. That's very obvious, but what's not so obvious is it's a simple Arial font, and then it's simply twirled, noise is added, and everything is bumped again, and it looks like something that could be described as cool or something similar. This one is pretty much the same. It's
Baroque symbols. Baroque symbols. I like that.
It's a glow rectangular. It's twirled to make the structure that you can see there. Noise is added, bumped, and the final result is like you see it here. This one is a little bit more advanced. It combines 2 or 3 basic textures. In the background you see concrete, which was combined with outlines, as I described earlier, to make the concrete look very dirty. And in the front is a simple glow rect again, which was multiplied 8 times and to build the circle. And again, the bump map comes into play. And those textures, the background with the concrete and the metal in the front, are combined via alpha, a simple alpha channel. And the alpha channel is basically the same as the bump map, which brings us to the next point. You have to recycle. If you want to store a lot of information in very little data, you have to recycle and reuse as much data as possible. For example, the cloud texture in the textures you saw is always the same. You don't need to redo a cloud texture every time and make it a little bit different looking. You take the same and use that for stones, for concrete, for everything.
And nobody noticed that.
You just use some of the deformation operators on it or something, and it's a very cheap recycling.
What we've missed to tell you here is the most important thing about this texture generation is the textures are completely resolution independent. We can zoom in independently, and it won't get pixeled, whatever. You won't see squares, and this is this is really important. I think they can be used at any resolution you want them, and it's no more work.
Another free bonus of this technique with generating everything is that all the textures we have are looping automatically. You really do not have to do anything. The clouds and everything is looping by the formula makes it loop.
By default,
by default.
Unless we rot zoom them, then
the rot
breaks
zoom
up.
destroys it.
Yeah.
But that's very good if you want to make games with it, because all the textures are looping typically.
This texture generation, I think it's interesting. It is interesting for everyone who's making games or who's doing textures. This is really advanced, and personally, I don't like to go back to Photoshop again for texture generation. It's simply.
Not me either.
This is much more cool, really, really.
Yeah, the texture part in our tools is probably very advanced already, but the meshes are not. If you have seen Krieger, you might have noticed that every forms we have in there are very simple. Of course, they are built from primitives.
Stick together primitives.
Yeah, sticking together primitives is basically all we have. We have the usual kind of primitives as cubes, spheres, and tori. And one of the most popular tricks is the subdivision, but that's not good for games. In demos, you can do pretty things, objects, by using the subdivision, but it's too much polygons for using it in games.
In intros and demos, of course, you have the full control over the scene. You know exactly how many polygons are on the screen visible, but you don't know where the player of a game is looking to, and so you have to be more careful with the polygons. So subdivide is not really an option for that.
What we used for the first time in Krieger was this kind of bending operators. They are used in basically every scene in Krieger. That's a picture from an unreleased part of Krieger. And you see, that as well as in the geometry itself, as in the corridor, everything is bended, and it gives the whole scene a much more natural look. One more nice thing is that if you have the bump mapping, you have displacement maps more or less for free. They were used in those two objects that you can see here.
Another recycle option.
Yeah. The roots use the texture for the bump map of the wood to make it look three-dimensional, and it deforms the polygons. And even more important, it is on the right side. I really don't know what this object is meant to be, but
it's rotating and it's cool. it's all it needs.
And it uses the bump map for displacement map too, and so the destroyed surface is really three-dimensionally distorted, and not only on the texture.
This is a very important point. Materials and lighting system. I think before Krieger we had just the standard multi-texturing, standard lighting. I'm not sure about F408, if that had multi-texturing already, but every production after that had at least 2 textures and standard DirectX lighting model. And this is pretty cool, and you can do very much stuff with that. Of course, we wanted more. We wanted more advanced stuff, and everyone was used to these kind of looks. And this was seen from the very, very beginning, from Krieger, where we had this standard lighting. And we begged our coders, come on, give us more, we want more. And they delivered. They gave us Pixel Shader 1.3 options, and we had new possibilities. And so nochmal weitermachen. And what the hell? This is a parameter set for the new material system. And
that's one single material.
Yeah, this is a material, and this is the parameters for that. And to be honest, we're using that for half a year now, and I still don't know what these parameters all mean. And it even doesn't fit on the screen. It's going much further. But the important thing is, with this material operator, we found that we can use 2 things. They were very important for us, graphicians, and maybe it delivers more. We don't know. Maybe we find out later. The next slide, please. There was bump maps and shadows. And wow, shadows. I mean, this is what we always wanted. Real-time shadows that light, when the light moves, the shadows move. And okay, these are sharp edges. This is something the coders have to work on, I think. And they will. I'm pretty sure they will, somewhere. And of course, bump maps. This was really a beautifier. And how this bump maps are generated is explained on the next slide. These are some of the weapons we did. And the funny thing about this is this bump map actually is used for that weapon up above there. And when I created the weapon, I never looked at this texture. I just edited it on the weapon itself. And when I was done with the weapon, I was satisfied with it. I looked at the texture and said, "Oh my God, it's that ugly texture." I mean, just look at that. But I didn't realize, because Yeah, well, it's all integrated, and you work on the meshes directly, and you come up with a beautiful mesh, and then you look at the texture and think, oh my god. Would anyone have done this in Photoshop and applied this to the mesh? Never. And this is the cool thing about the tool. You simply can't forget about it. At least only the results are what's counting, and that's really cool. Oh, and just another thing, an important trick that Five found out. Always, do you want to say it yourself?
It's a good trick to use the bump map not only as a bump map, but render a slight version of the bump map into the texture.
Yeah,
it looks better when in a game you cannot know from where the light is coming at any time, and sometimes a light is just too exactly on top of the texture, and there's no bump mapping left. And if there is,
then it gets flat, totally flat. And this is what happened here. This was the original texture I applied before I did the bump map. Then I did the bump map, applied that to it, it looked good in the single view, and then I put that in the game engine and ran through the level and thought, oh, this is looking very dull. And then I applied the bump map again to the texture, and well, it looked good, quite nice.
Okay, another nice feature is IPP. That's real-time image post-processing, which is very popular in demos now.
Yeah.
And the most important aspect of it is probably the glow, which you can see on the bottom of this page. For that you simply take the original picture, make it a lot darker so that only the brightest parts of it remain, blur them, and add those blurred picture to the original one. And you have the glowing at
every
all
frame in real time, so with the whole scene.
That happens every single frame. But you can do a lot of more stuff with image post-processing, but it's much more subliminal. You can have all kinds of color correction. You can also have contrast and sharpen in real time.
And soften. You can blur the whole thing, which is what
blurring
happens most.
Is not a good idea.
Yeah, this is
actually
avoid blurring.
Yeah, it's a big problem if you add this blurred glow. Because it often makes the picture look a lot more blurry. And,
it's even here. You can recognize already here. This is a much sharper image, and this is a really good.
But that's not because
IPP.
of the blur. That's because of the resolution. The one on the bottom is low resolution.
Okay. Okay. Animation characters. This really made my headaches. When we started Krieger. I just tend to this English stuff. Damn, it's Krieger. It's a German word. We didn't know which was the best approach to do characters and animations, and we used a lot techniques before we used Krieger. And can you the next one, please? This was sticking primitives together, which is a quite cool thing because you get forward kinematics for free. By the way, we create them. This is, I don't know if any, okay, I know a few of you, but we have this operator stacking system where the creatures are created and everything. And basically, this is the jaw of this little dragon, and this is the rest of the head. And if I transform this, if I move that, the whole jaw is dropping up and down. Can you, this the next slide? That's seen here. And this is quite cool to animate stuff because it's easy. It's in the system from the very beginning without even planned. But the problem is the downside of this is very hard to do walking animations with that, if not impossible. It's possible, but it doesn't make fun. And the most important part, it looks cheap in most cases. I say this is just like N64 style, what they stick primitives together, and we are far away from that nowadays. But for size. The next thing was we did for Candytron was real skin characters done in an external 3D program, imported them and used them. This is really good quality, but it's much too expensive. The mesh, bones, and animations for this character are 12 kilobytes. And even if that sounds not very much, for a 96 kilobyte game, think of 5 creatures. Well, it's too much. So the solution for that was the walk operator. Basically, we have this new operator that delivers inverse kinematics for feet, automatic footstep system, and so the characters touch the ground really. The problem is everyone who knows automatic footstep systems, for example from 3D Max or whatever, they don't move realistic. They don't have any specialized characteristics when walking. They just walk like this, and they don't move. And this is why the third thing is so important. We have the possibility to trigger other operators for forward kinematic. So it was possible to use this information we get from the footstep system to trigger other animations. So it was possible to animate the hands and to define the walking style of the creature. And so we got individual walking styles. That was really cool. But it also meant we had to stick all that stuff together in the editor, which meant sticking primitives together again. No real skinned characters, which was a bit sad. These are some test scenes, test characters that failed. Mainly these three. This wasn't even developed to the end because we didn't want to have human characters in the game. So we dumped that. And yeah, the next slide. These are the actual characters in the game. And I think it's a pretty good result. Materials, meshes, animations for all these monsters are 6.3 kilobytes, which is the half of the one model I showed before. So this was definitely a good solution. We'll see if we use that again. Yeah, next. Yeah, this is all important. Dozen collisions. Actually, it's the same for us. We have this collision cube over here. This is a very, very important operator. It's invisible. It's a cube you can place in the scenery, and you can define how he behaves. He has over there mode. I don't think that you can read that. It has add, sub, and zone. Add and sub is for collision. Whenever you're able in the game to move somewhere, you're definitely inside a collision cube. When anything happens in the game, like a door opens, you probably entered a zone. And that's all. It's a really simple thing, easy to set up for graphicians. And yeah, it somehow works.
Do we have time to show the animations?
I don't know. How late is it?
15 minutes.
Okay. Yeah, then I will show you some cool stuff, I hope. Where are we? There. Oh my God. Okay, kannst du das halten für mich? Okay, I have to load the file. Geht so, danke. Where is it? There. Oh, this was fast. Okay, this Hellbug. There. Just want to show you the walk operator, because if you see him in action, you know why I'm so excited about that. And okay, so I give this to microphone. So there we have this creature, nice guy, and there's the walk operator. It's not interesting, but what happens if I translate that guy? Okay, so I just rotate him. Oh well, what's happening? So, whoa, too fast. He automatically steps, and this is really cool, I think. Yeah, I played a lot with that. You can walk backwards and sideways, and yeah, this. Just working. It's so much fun, really. Okay. This I need to show that. Just close the application. Back to the slides. Okay. Yeah. And this is what went wrong. Basically a lot. Damn a lot. I talked about the collisions. I don't know how many emails we received where people complaining about that they stuck in the door. They can't move anymore. Yeah, we know. I don't know, 100 emails or what. This is a really big problem, and we're about to fix that. Well, we never did a game before, and things just happen like that. And the creatures do exactly the same thing. They get stuck somewhere, or they behave totally not. And this is a problem. Another big thing what went wrong was we did the game in a hurry, really in a hurry. We wanted to put it out at breakpoint, and well, the week before we released the game, it worked quite stable. But we did a lot of fixing in the very last minute. And while we fixed that, we put in other bugs, heavy bugs, forcing producing the game to crash while loading, or getting slower and slower. Even if you have the right requirements, system requirements, it doesn't work, and stuff like that. And really, believe me, we will fix that. At least we try. Yeah.
Another error that was my fault was the level design. This what you see here is the level that was used in the beta version of Krieger from the very top, and you see it's pretty linear. Actually, this is only one fifth of what is ready. There's much more part, a much bigger part of the level finished already, but it wasn't used. The rest of it is a little bit less linear, but okay.
When you showed me that yesterday, I thought, you're joking, aren't you? I said, no, that's exactly the level from the top. I said, no way.
Another thing that many emails and people mentioned, it is way too dark. The picture again speaks for itself. You see the glow and nothing else. The problem with that was, or the reason for that was...
Who can see the creature? There's a creature in there. It's a searching pic.
The main reason for that happening was that I adjusted everything, the colors and the brightness, on a TFT display. And I turned my display...
Bright one. A bright one.
Yeah, no, I turned it to as much dark as possible. But on every monitor, it was even much darker. And that's why the whole thing is so dark.
So buy cheap monitors. I just really do the productions on them. The worst thing you can get probably looks better on other monitors then. This screenshot doesn't illustrate that too good, but another problem is we didn't get light maps. So everything in Krieger looks a bit more flat than it should. We tried to include light maps, but they were just too slow. It would have taken half an hour to pre-render them for the whole level. Yeah, which is no wonder, because we tried to use Radiosity light maps.
Yeah. And but, it just didn't work. It will always look a little bit more flat than full price games. And another thing is the textures simply have too much contrast. Every single texture is so full of details that in the end there's so much different detail that it looks like no detail. The human eyes or the human brain rather, is not used to get so much information. Probably the most or biggest problem was making a 96 kilobyte ego shooter with 6 people in a spare time is impossible. And that was what we thought in the first place. And in the end, it turned out to be right. It was impossible, and that's why it looks like it looks, and why it crashes, and why we didn't have time for gameplay and everything.
But while we were producing that, we were quite optimistic that we still can do that. But in the end, it showed us, no, it's impossible. Yeah. And this is the most important thing I learned from this game. I truly respect. I really truly respect game makers who yeah, die schaffen das. Ich weiß nicht, don't know the English word. But,
yeah. Okay. Probably everyone knows the scene. It's pretty overused already, but I think it illustrates something very well. Yeah. The last question is the future of 64Ks and what will be possible. And the answer is, of course, everything. And yeah, why I like the screenshot is at some point when doing the textures for Krieger, it really felt like I was able to look inside the matrix, just like Neo does in the end of that film. It felt like you see the world, and you're not seeing it anymore as the world itself, but as the math behind it.
Yeah, the patterns behind that. Yeah. Patterns that create the world.
Patterns everywhere.
And this is, we've been joking yesterday, I think, Boise, and I don't know who was else there, Mumak, and we said, basically we think the next step is 4 kilobyte intros replace 64 kilobyte intros, and 64 kilobyte intros replace demos. And demos get, well, just for the fun. I mean, the real competition will be that next move. And after that, yeah, everything. It's no
I'm
limit.
Pretty sure we will see something of a next step at this party, though not from us.
I think so,
Yeah. That's it. One person is missing, that's KB.
KB, he also was involved, but he wasn't there. This is a screenshot photo we took from screenshot. Geeks, just geeks. Geeks say screenshot. This is maybe a nice story to tell. We once in a year, mostly in December, we rent a flat, we rent a house in Denmark. We're big Denmark fans, and for 1 or 2 weeks, and it was a swimming pool and stuff like that all together, and we're working there, and working on our production. Most of the time for the party, this doesn't exist anymore, but we still have these meetings once in a year, and this is where most of our intros and demos are created. And this is from the last Krieger Elite House, we call it Elite House, to honor and praise the great Elite group. We are following their greatness. At least we try to. Of course, we fail. No one is as good as Elite group. Yeah, that's it. Are there any questions? I don't know if you have enough time.
Yeah, 2 minutes.
2 minutes. So no, okay. Then.
Okay,
no
ladies
questions.
and gentlemen, Barbara from Germany. Big hand.
Good to hear.